It's really wigging out now. All right. Mr. Zion, tell me what you've done so far with this. One, and you got one. Two is 1/2. 3 is 1/3. 4 is 1/4. Got any more points? 5 is 1/5. -1 is -1. -2 is -1/2. Then -1/3. Then -1/4. Then -1/5. Now what? 0 is undefined, which means you can't touch this line at all. There's no value there at all. Since you're betting that, let's pick a point closer to the axis. Let's try like a half. Well, I'm not going to bet against you, and I probably know the answer. All in. If I put in a 1/2 here, that means I have to flip and multiply it, right? It's 1/1/2. Flip and multiply, I get 2, don't I? So 1/2 is 2. 1/3 would be, I was hoping everybody just yelled the answer out. 3, thank you. And 4, and then 5. Since I can't cross this line, it looks like what's happening is I'm going towards infinity. Yes, the board is having its moment. And then, do I need to pick some points, or can you figure out what's happening on the other side? You know? All right, so I'm going to go like this. And so there's a vertical asymptote right here. All right. Now some things we should notice. We should notice that the point 1,1 is on my graph, and the point 2 1/2 is on my graph, and the point 1/2 2 is on my graph, and that the point -1 is on my graph, and then the rest of it's going to look just like that mirror image over there. Correct? Just calm and look at your face. Did I make that? Did it make sense? Okay. And that there's an asymptote I can't cross this way, and by the way, there's an asymptote I can't cross this way. Horizontal asymptotes, which you hardly ever talk about because they're weird. And if we expose Algebra 2 students to that, they'll go all crazy, and we don't really need to do that. So, but we're in trig now, so we can start talking about horizontal asymptotes for the first time in a while. That said, so far so good? Now, here's the asset question by which we will save a lot of work if we know how to do it. If we don't, we get to do a lot more work. And we're going to put all that pressure on Miss Manship. Emily Manship, for big, saving us lots of work. If I draft the exact same thing, but I tack on an x plus, I tack on a +4, what is my graph? How far?
4.
Nice. That's it. That's the answer. Yeah. So all you have to do is take the whole entire graph and make it go up 4. Got it? I mean, you can redo this table, but if you think about it, if I add 4, that's all I'm going to do is add 4 to each of these numbers, which is going to tell the whole graph to go up 4. So that graph should look like, if I do everything right, my calculator calculator, my computer does not completely melt down. Oof. It's struggling. 1, 2, 3, 4. So now I have an asymptote this way and an asymptote this way. My graph goes through that point there and that point there. 1, 1 and negative 1, 1. It goes through 2, 1/2, and it goes through 1/2, 2. Going to do the same sort of thing here. Sketch it. These are called rational functions. When the parent graph is 1 over x, they're called rational functions. Whew. And this manship saved you guys some work. Mr. Sussman, pressure's on you now. Have you sketched this yet? I'm going to say the next one, but first of all, did you sketch this one? Are you ready to discuss the next one? Yeah. Okay, good. Let's discuss the next one. I have 1 over x plus 2. What happens there? Oh, we're going to have to draw this one out. It's a bad one, too. Oh, let's make a table and everything. Boo, hiss. Boo, hiss. Does anybody want to, do you want to phone a friend?
Yeah.
You got one choice. After that, I got to guarantee the whole room doesn't know. Okay, Gathniel doesn't know. We all know we don't know, right?
Is it like his whole answer wrong? Or is like just part of it wrong?
Lots of it was wrong. I don't know if whole answer is wrong. Is the thing. All right, let's do it. We got to make a table. Table time. Makes me want to cry a little on the inside. So, if I plug in a negative 2, oh, that's not good. Plug in a negative 3, I get negative 1. Do I not? Yep. If I plug in a negative 2, I get undefined. If I plug in a negative 1, I get 1. If I plug in a 0, I get 1/2. I plug in a 1, I get 1/3. Whew. So negative 1, I'm at negative 3. No, that's backwards. Negative 3, I'm at negative 1. That's better. I'm undefined at negative 2. At negative 1, I'm at 1. I'm at 1. 1 would be up here. And then at 0, I'm at 1/2. And at 1/3, at 1, I'm at 1/3, then 1/4, then 1/5. All right. What happened to my graph, Mr. Sussman? Save us. Shh. Sussman.
Oh, it got rotated.
Rotated?
No. I guess
Left 2?
Yeah, that was my first guess.
You said stretch 2.
No,
I heard stretch and compress in that sentence.
well, that was my first guess.
Well, you'll guess 3 things then, dude. Pick one. Yeah, 1 guess per try. All right, so shift left 2. Good? That's what happens when you put a number inside of the bottom, right? All right, everybody try number 3. Who should I pick on for this one? Oh, who do you guys trust? You guys all looked at Gathniel like, oh, got Gathniel? Noble! Noble, what happens when you put a 2 in front?
Stretch 2.
Stretch by a factor of 2. All that means your y values are now twice as big. If it's negative 1/4, it becomes negative 1/2. If it's a negative 2, it becomes negative 4. Okay, stretch your y values.
Wait, can you draw number 3?
I will.